Hi, today we are going to learn how to use YOLOv5 for object detection. So we will use this test image and try to detect all the objects inside this image. We will run through all the process from the starting point until getting these results. As you can see, we are detecting all the objects like persons and car in this test image. And you are most welcome to subscribe my channel. Okay, so let's start with the installation part. I will not do a full detailed installation, since you can find the full installation on this video. I will leave a link here in the upper corner so you can download and follow the full installation. This specific video tutorial is deal with YOLOv5 segmentation. However, all the installation process is basically the same. So I will leave a link for this tutorial. I also will leave an installation txt file, and you can see the first line in this installation file, name install.txt, points to this video tutorial. But let's cover quickly all the process. First of all, let's create a conda environment. Let's name it YOLOv5. It will be based on Python 3.8. And of course, we will activate this environment. Then we will choose a folder, and we basically would clone the YOLOv5 repository as a subfolder under our folder. We can use I basically will use a tutorial folder, but you can choose whatever you like. Then we will clone the YOLOv5 repository, and the next process is choosing which version of PyTorch you should install in your local machine. So in order to do that, you should run this command, nvcc -version, and you can see what is your CUDA version. It should be something above 11. I'm using 11.8, but you can choose your own version. But it's really important, if we go to the PyTorch, let's find the PyTorch website, and if we go to all the install previous versions, you can see that the last one is 2.3, and this support 11.8. So if, for example, you have another CUDA version, let's go down for an earlier versions, and let's go down, for example, here, this PyTorch version 2.0.1 supports CUDA 11.7 and 11.8. So this would be the command in order to install it. Let's see another one. For example, if you have CUDA 11.6, you should install PyTorch 1.13.1. So this is the process. If I go back, I'm using 11.8, so I copy this command from the PyTorch website. Then you have to install a more relevant Python libraries that are required by the YOLOv5, like GitPython, Matplotlib, NumPy, and it's really important that the version will be above those versions. As you can see, some of them are above, some of them are not. You are not required to a specific version. However, when you installing the Ultralytics version, it should be this version for YOLOv5. Then you have to install OpenCV, but in order to do that, or before doing that, you should uninstall OpenCV headless, which is OpenCV without the visual functionality, and then reinstall the OpenCV with version above 4.1.1. So this is the installation part, and as I said earlier, you can follow my previous video that dealing with segmentation, but as I said earlier, the installation process is the same for segmentation and for object detection. Okay, let's continue to the next phase. So if you have done all the installation process, you should create a subfolder named YOLOv5. Mine is under the main folder tutorials. So if I go inside YOLOv5, these are all the 5 that were cloned from the GitHub repository named YOLOv5. In order to do all the object detection, and we will start with a simple object detection, we should copy one image into this folder. So I copy this image named hovering.jpg. If I open this image, as you can see, there are a bunch of people in this image, and there are also several cars, and we would like to detect all the objects inside this image. So I will leave this image along with the code, with the link under this video description, so you can type it along with me, or you can download it by yourself. Another important issue, I'm using VS Code, so you should define your main folder as the YOLOv5 folder. So if I click open folder, and then let's go to C, I put it on tutorials and YOLOv5, and I will select this folder. So this should be my main folder. This is, for example, all the out-of-the-box code from the YOLOv5 repository, so we are going to use it. Also, we have here our image, our test image, that we will use it next. Another issue is choosing the right interpreter. So I will click Control Shift and P, and then select interpreter, and we are looking for our Conda environment. I name it YOLOv5 tutorial. So it's really important to select your right interpreter. Great. So now we are ready to run, to code our object detection based on YOLOv5. So now we are ready to start the coding part. Basically, we will need only one Python file. So let's create this file, and we will name it YOLOv5 simple object detection.py. Great. So we will start with importing the PyTorch library and also NumPy and OpenCV. Then we will specify the path for our image file that we will prepare to analyze, and we will import the file and read it using the OpenCV library. Then we will show this image just to double check that we loaded the file properly, and basically we are expecting to see our original image as is. Great, so this is our image. Let's continue to the next step, which is loading the pre-trained model. We should load the YOLOv5 pre-trained model. As you can see, there are several types of object detection model, like 5N for nano, 5S for small. We will choose the small model. So now we will load the pre-trained model from the PyTorch hub. As you can see, we are looking for the Ultralytics YOLOv5 under torch.hub, and we are loading the YOLOv5S model. Great. Now we have to choose a device. We will set the device to GPU if a GPU is available, otherwise we will use a CPU. And next we will use this device with our model. Let's run it just to double check that the model was loaded with no errors, no mistakes. So great, this is the original image and the model was downloaded with no error. Next, we will wrap the image as a list since our model expects a list of images as an input. The next step is the prediction. So basically, we will run our model, run the prediction using our image. The results of this prediction will be stored in a variable named results, and then we will start investigate this variable, and we are expecting to find all the objects, all the labels, and all the bounding box inside this results variable. So here is the prediction command, and now we are printing all the results. We don't have to display our original image. Let's run it. So look at the log. As you can see, we discovered 11 objects, 11 persons, 2 car objects, 1 cup, and 1 chair. Great. So we are making progress, and let's continue to the next step, which is extracting the labels of those objects. So this command basically is extract the labels of the detected objects from the results variable. We select all the rows and the last column from the first element of the results, and that will be all the labels that were detected. So let's print the labels and see what we got after the prediction. So after running and printing the labels, we're expecting to see numbers. The numbers indicate the value of these labels. So as you can see, we have 0, 0, 0, and the value 2, and the value 41 and 56. So next we have to discover what indicates those values. So now we have to extract all the labels, all the pre-trained available labels. So in order to do that, we will use the model.names that contains all the relevant labels in our model. The model is based on Coco classes, so basically we have 80 different classes. So let's get the list of those classes. As you can see, from 0 to 79, 0 indicates a person, and 2 indicates a car, and 41 indicates a cup, and 56 indicates a chair. So now we have the label names. So let's learn how to grab these names out of the label number. So let's, for example, define a class 0, and let's discover what is the name, the class name of class 0, and also for the class 7, just for example, and let's print those 2 example labels. Let's run it again. And as you can see, 0 is a person and 7 is a car. Great. So the next step is grabbing all the coordinates, or basically all the bounding boxes of the detected classes. So we would like to draw a rectangle around each of the detected classes. So in order to do that, we will use the chord variable, and this chord variable is extract all the box coordinates for each detected object, and we will get all the values until the last column from the first element of the results. So once again, let's print the coordinates variable. And you can see, for each of the detected objects we have 4 values, which indicate x1, y1, x2, and y2, which are the corners for our rectangle. So now let's merge all what we learned so far and run a for loop for all the detected objects. So first of all, we will get the bounding box of each detected object, and then we will check the confidence score if it's greater than 0.2, and if it's greater, then we will grab the 4 values. So what are those 4 values? x1 and y1 are the top left corner of the bounding box, and x2 and y2 are the bottom right corner of the bounding box. And after capturing these 4 values, we will define a box color. So we will draw the rectangle of using this color. Let's define it as green. And next we will use OpenCV for drawing the bounding box on our original image using all the values like x1, y1, x2, y2 and our color and how thickness is the rectangle. Then let's extract the class name as we learned in the previous step, and we would like to display the class name and next to the rectangle, so we will use the put text function and display the class name near our rectangle. And finally we will display our original image that already contain all the bounding box and the class's name. And let's run it. As always, you are most welcome to subscribe my channel. I hope you enjoyed this tutorial as well. Thank you and bye bye.